inside the function. Good. So these are the things you guys talked about. Line 2, we were missing the num1 equals 3. Line 3, we're missing equals taco. Line 4, we use row equals. Line 6, we're missing a colon. And line 8, we indent return.
I have a question.
Yes.
Are we able to, you said you can't just put num2 and equals 3. Can you put those in the bracket after the big sign?
You mean like this? Yeah.
Okay.
Yes.
Why do we need brackets after return?
But we don't need brackets.
But it's not going to think it's a function if you put brackets.
No, so it doesn't actually matter. You can return is a keyword, but if you put brackets around it, if you have more than one thing, like let's say you're returning, come on guys. You have all people with me. Shame. Anyway, so if you have an equation, then let's say you're returning a plus b with variables a and b, so you can put that in brackets so does that person returns it. But it doesn't actually matter, you don't need the brackets. But they're not wrong. Any other questions? Yes, all in the back.
Yes, just for the deal with the equal signs again, like when we use 2 and when we use 1.
I'm sorry?
So the deal with equal signs, like what should we use 2 and what should we use 1?
Okay, so the single equal sign is what we call the assignment operator, and we use that to assign variables. So we can say a equals 3 or b equals 4, and let's assign variable 3 to a or 4 to b. But when we use a double equal sign, it's called comparison operator, and we're comparing these two variables to the same. Does that make sense? Yes?
Yeah.
Okay, perfect. Does anyone have any questions about this? The way I fixed it? Okay, good. So now given this function, I'm going to test your knowledge of printer returns. If I run these two different things, so first I call the function on the arguments 3 and 1, and then I print the result, versus if I just call it on the arguments 3 and 1, what do I expect to see? I'm going to give you a minute to look at that first and ask some questions. Yes. Who had a question? Yeah.
This is still but you're defining
Sorry?
But you're defining the variables.
I can't hear you.
The 2 variables in the function.
Yeah.
num1 and num2.
Right.
This is a really nitpicky thing, but in general, it's just like a stylistic thing where you try to keep that consistent.
Yeah, that was actually one of the tricks I had, is if you think it's a mistake. The take-home point of that is it doesn't matter what you name them, right?
Yeah.
As long as it's consistent, it's fine. Stylistically, yeah, you're right. We want to keep it the same.
I know when you make an actual table, it's going to go around just wondering.
Right. It looks better when they make the same
Yeah.
connection. But this is just a style. This is just a little trick to make sure like nobody thinks it's an error. Good point though.
I think I'll give you a quiz.
All right. Any more questions before I ask you questions? Yes.
Are we allowed to hate on the function but not have to actually?
No, you're not allowed to hate on it.
Like, would that be a valid thing that we would say is like wrong with the function?
Well, it's not wrong. It's functionality, right? Okay. So now I'm going to ask you questions. Okay. Who says the output for both of these are the
You got a question?
Yeah. Question.
When we, on the final exam, when we're
Yeah.
given something like, what's wrong with this function?
Sure.
Are we just not supposed to take stylistic errors into account at all then?
I'll let you know.
Okay. So first of all, if I run these two things here, who says the output's the same? Hands up. Who says the output's different? Okay, good. So can anyone tell me what I should expect to see in my shell after I print, after I run the first code here? Yes.
The first one, you'll just get food.
I'll just get food?
You get tacos and food.
Okay. Who agrees with that? And who says he's wrong? Okay, what are you expecting to see?
I'm expecting to get food.
Just food?
With the explanation. Yeah.
Okay. So this is actually what we get. And I'll go over why in a bit. What do you guys expect to see from the second one? Just tacos, right? Who agrees with that? And who says fatigue strong? You again. Okay. What do you expect to see?
I expect the same thing.
So you're expecting the upper to be
Yeah,
exactly the same. Okay. Well, this is what we actually see. So unfortunately, you're wrong in both cases, but that's okay. That's okay. Can anyone tell me why? Yes.
Because it, for the first one, you're printing the result, so you'll get the result, which is tacos, plus the return. Whereas with the second one, you're not going to get the return coming in stored.
Exactly. So it's like you said, in both cases, we hit line number 3, right? So prints tacos. So we'll see tacos in both cases. But in the first one, because we're printing the result that are returned, we'll see food. This returns food. But in the second case, we actually store the return value anymore. We're never printing it. So we just see tacos. So quick recap. The tacos, right? This comes from line 3 in both cases. And then we see food because we're printing the result, which came from line 8. Does that make sense? Yeah? Any questions? Yes?
So the idea is that the result is not like printed unless you store it in a function that you print.
Well, it's like I said earlier, right? When you have print and return, print shows that you doesn't store it anywhere. Result, if you save it into a variable, like in this case, it's stored into result, and now I print it. So the first time I stored it, it's now, the word food is stored into result, and now I can print result. So print shows you right away if it's stored anywhere. Result stores it, but doesn't show you until you ask it to show you, right? And I asked to see it when I printed it. Okay. All right, so the next little bit is conditional statements. Remember the general structure of this is going to be something along the lines of what I have here. If some condition is true, do something. Else if some other condition is true, in Python we call it elif. We do condition, if some other condition is true, we do something else. We can have infinite number of ifs or elifs. And at the very end, to catch all the other cases, we have an else block, right? This shouldn't be new to anyone. Any questions about this one? Yes. I'm sorry? Elif stands for else if. Well, it stands for else if, right? So I'll get to the difference between if and else if in a bit. So if you have multiple if blocks, they'll all run as long as all conditions are true. With else if, only the first true one runs because it's exclusive. Any other questions? Yes.
You have multiple ifs, then in the middle, then you can change the order and it doesn't matter. But
Yeah,
else you can't.
Right. So the difference between if and elif, or in elif stands for else if, again, is that multiple if blocks can be executed, but only one elif block can be executed. So basically, if I have like 10 if conditions and they're all true, then all 10 of those conditions will run. With an elif, they're mutually exclusive, meaning that only one can run. Right? So it's a combination between else and if. Any questions about that? Yes.
We'll say if you're writing a code and you have 2 if functions, and by the nature of
Sorry, if functions or if blocks?
if blocks, sorry.
Okay.
So if you have if this, then this, and if this, then that, but
Right.
the 2 if statements are by definition contradictory, you can't have one without the other. Can you keep them both as if, or should you still do if and else?
Now, if they're contradictory, you probably don't want them both as ifs, right? Because there's an else block for that. But let's say you were to have them both as if blocks, and only one of them were true, then only the true one would run.
So I'm like from a correctness point of view, if you were writing it, if one of the blocks can't be true while the other block is true, should you still do if and elif, or is it okay to write 2 ifs? Because
It would be better to write if and else in that case, right? Because let's say we have something along the lines of if A equals 3 for some variable A. Does it make more sense to say if A equals 3, do this, else do that? Or if A equals 3, do this. If A not equal to 3, do that. Because it does the same thing, right? But stylistically, one is just better than the other.
I get the feeling that that's not quite what you're asking, right? Like, okay, I guess you're saying this. I guess. And then, are you saying that like, okay, let's say we're using the condition A equals 3, right? What else would we write here? Like, so if you're trying to make it such that this code runs when A equals 3 and this code runs when A does not equal 3, I guess then you should just use it if and else, right?
Well, yeah, but what if I want that other code to run when A is equal to 2? And like A can't equal 3 and 2.
Oh, then it doesn't matter if you're using if or elif, because if it's exclusive, and one more return at a time, it doesn't matter if it's if or elif, right?
Okay, so it doesn't matter.
Yeah, so you do this, if A equals 3, do this, elif A equals 4, do that, elif A equals 5, do that, else for every other case, it's else.
I would say I prefer this slightly, but it's not going to be the kind of thing that you get deductions for. Yeah. Yeah, right.
Generally, the rule of thumb that I use is if only one can ever be true, I use elifs. And if multiple can be true at the same time, and I want them to run at the same time, then I'll do ifs. Any other questions? Yes.
Where did you use elifs exactly?
Sorry?
Like, when do you normally use elifs instead of wait?
So it's like you said, in the case where let's say, remember that storm category lab you guys did? Right? So you return something if it's within this range. Else if it's in some other range, you do something else, right? So in that case, you should be using elifs. Not that it matters if you use ifs, because it'll only ever be true for one case anyway, but just stylistically, you want to show people looking at your code that only one will ever run at the same time, so it makes it more clear.
So if there is elif in the scenario, you get marks off.
If multiple things have to happen and multiple ifs have to run, if you use an else if, then it won't actually run. In that case, you'll lose marks. But if they're mutually exclusive, it doesn't actually matter.
Okay, so think about this example, right? Let's say we want to go back to that storm category thing. I don't remember what the numbers were, but it involved wind speeds, and if the wind speed is over a certain number, it's this category. If it's over another number, it's another category, right? So let's say we were to do this. Category equals, 1 for wind speeds over 60. And then if I were to try to write this, let's say for speed greater than 70, let's say for speeds greater than 30. Let's say for speeds greater than 30, let's say that's category 0. Category. Okay, now this code, can anyone tell me what's going to be wrong with this? Is there something wrong with this? Yeah, yeah.
If speed is, say, 70,
Uh-huh.
then both the conditions will be true, so the category will be assigned to
Ex-
one time.
Yeah, exactly. So let's say that the speed we're actually looking at is, 70, right? 70 is going to be greater than 60, so this will run, right? We'll set category to 1. But 70 is also greater than 30, and therefore we'll set category to be 0. But really, we should not be setting category equals 0 because, 70 is greater than 60, right? So if we were to replace if with elif, then that's going to prevent this from running because we've already found that speed is greater than 70, and therefore we're not going to run this. Okay, so this would be the correct way to do it. So in the end, it's okay if you use ifs, and it's okay if you use elifs as long as your code's correct. All right. Okay.
Yeah. Yes.
So like, if you're using F for like 2 parts, and then not the same thing that you do like F something and something. So you can just write one F, but not like having a lot of F.
It depends on what you're doing, right? Because you can have if blocks inside if blocks. You can have different things inside an if block. So if you only have 2 ifs and they're nested, then yeah, you can combine them. If you're not doing anything for the other case, right? Let's say you have something along the lines of if A equals 3. So if A is greater than 3, And then in here you have if A is greater than 4, you do something else, or else you do nothing. Then you can combine these into just if A is greater than 4. But if there's more cases than that, you don't want to combine it for the sake of combining it. You only combine it if like both have to run at the same time, or else something else happens. Okay. Okay. One question for you guys: how many else blocks am I allowed to have?
No.
1, right? I can only have 1 else block at the very end that catches all of the cases that fall to my else. Okay, good. And now we're going to look at some code again. So this code actually has a lot of questions you guys asked earlier embedded in it. Can someone tell me? First of all, can someone tell me what's not good about this code? I want to draw your attention to lines number 1 through 3.
So goodbye will never be printed because the if statement with A does not equal B is contained within the if statement of A is equal to B, so both cannot be true at the same time.
Right. So in this case, we have if A equals B, if A not equals B, print goodbye. This will never run because if A is equal to B, you got it in the first place, then A can be not equal to B because you already know it's equal to the previous line. So line number 3 will never run. Good. Anything else? I want you guys to focus on lines 4 through 7 this time. Can someone tell me how to simplify that? Yes.
If A equals to, okay, if A equals B equals print no.
Okay, yeah, so that's kind of the idea. We notice that all this is within the same block that says if A equals B. So we know that all the way up to line 7, A and B are equal, right? So if A is equal to 2, then hello is going to be printed. If B is equal to 2, then world is going to be printed. But we know that if A is equal to 2, then B is also equal to 2. So in this case, these lines 4 through 7 will always run at the same time. So you combine that into one big condition, right? What if I change it to this? What if I change it from if to else if? Can we still combine them?
Yes.
Yes? Why?
That A equals B. Then,
Really? Actually, if we change it to else if, this line will never run. What did I say about else ifs being mutually exclusive? Right? So remember that else ifs are mutually exclusive with if blocks and other elif blocks. So that if block was true, this elif block will never work, even if it's true. So in this case, we know that because A is equal to 2, if that ran, then this one will never run. But then this one can't run independently because we know that A and B are equal, right? So that's that code. Okay, looking at these lines here, is there anything you can do about this? Is there any way to simplify it? All the way in the back. Right. So this is that case that you guys asked about earlier, where can we combine it if there's only one thing inside this elif block? And the answer is yes. So you can combine it to just be this, where we bring up this if block into that elif condition, because we know that the code in here will only run if A is equal to B and A is not 4 and B is not 8, right? So we can actually just combine this into one block and print through in this case. Okay, now we're going to focus on the last 2 lines. When will this else block run? What has to be true for this else block to run? Somebody? What's up? Yes.
When A is not equal to B.
Exactly, when A and B are not equal. Why? Why do we know that? Yes.
Because you set the first condition that if A is equal to B, second equals to
Right, so it falls through both the if and the else, it'll go to the else, right? And it'll only fall through both if A is not equal to B. Good.
Can't you just remove lines 8 and 9? Because if A does not equal B, then that whole condition in line 8 will be false.
Yeah.
Okay.
Okay, we can just simplify all that into this. We can take all of that and simplify it into this. Making all the changes you said earlier. Yes.
Why do we need an else statement with A is equal to B? Why can't we put that inside the if statement with A is equal to B?
We can. Yeah. Because because we want to do something if A is equal to B, and it's A not equal to 4, B not equal to A, can actually go right into this if. I just want to show you the structure of this if, else, and else. Which is the same thing you were asking about earlier, right?
No. In the right side, lines 5 and 6, line 6 will never run. Because if A is not equal to B, then the condition on line 5 will always be false.
If A is not equal to B,
So if line 1 doesn't run, then the line 5 is always false as well.
let's see. Did I screw up here? I might have screwed up here.
Sorry.
I might have screwed up here just a little bit. Yes, he's right. You guys get the idea. It's one mistake.
What's the problem?
Huh?
I don't get it.
Sorry?
I don't understand what the problem was.
Oh, the problem?
Yeah.
Basically, if line 1 is not true, then lines 5 and 6 are never run.
Yeah. You just put if there?
Yeah.
But if you put it there, that's going to change the behavior of the else at the end.
Mm-hmm.
You know?
Yeah.
Line 5 is not supposed to work.
So how can you say, for example, if A equals to B, if those are not equal to 4 or not equal to 8?
You can just add that condition inside the if block, right? So if you indent the elif and take out the A equals B, if A is equal to 2, you print hello in the world. But if neither of them are equal to 4 or 8, then you print food.
So wait, does it say like, does it show that A is not equal to 4 and B is not equal to 4 in that statement as well?
Well, so in this case, you just want A and B to be equal, but then neither of them are equal to 4 or 8, right? So just add as a separate condition under the if A equals 2.
So you don't have to specify and A is not equal to 4 and B doesn't equal to 8 in this case?
Because you know that A and B are equal in that case.
Okay.
So you just check both of them are, you can just check one or the other. Yes.
Didn't we just do in the previous example though that we needed to separate those different conditions in our if or elif statements, like the A equals B and A doesn't equal 4? Didn't we just do that in the first example and that was something that was incorrect?
Oh, that was.
It's an and though, right?
Yeah, so don't we need to have an and in the elif
No.
statement?
No. So you're just comparing if things are equal to something else, you can keep doing it in a chain. But if you're doing ands, then you need to be specify what you're anding it with.
Oh.
So if you think about it this way, and takes 2 booleans on each side. So whatever's on this side of the and has to result to a boolean. Whatever's on the right hand side also has to result to a boolean, right? So you go true and false, false and false.
Oh.
But then let's say in that case we had earlier, we would have had true and 3, which doesn't work.
Okay, so if it's all like within, it can all be the same condition. Yeah, they can all be like kind of true together.
Mm-hmm.
Okay.
Good question though, yes.
How do we know when we're doing not equal to 4, not equal to 8? Like, I know it's comparing
I can't hear you, sorry.
because it goes with n in between 4 and 8. Like, because I feel like it would look at it's 4 and not equal to 6.
You can go A not equal to 4 and A not equal to 8. You can do that.
I think she's right though. I think there's a bit of a problem there.
No, that's fine.
It is?
I can check that now.
Really?
Yes.
Okay. I've never chained the not equals stuff together before.
So you can actually chain greater than equal to,
Uh-huh.
less than equal to, greater than equal to, or just equals as a chain of like however long you want.
Yeah, no, I'm saying it's just like how do we know that when we say not equal to 8, it's still looking at 8 equals to 8.
What do you mean?
Keep in mind that the condition checks that that A and B are equal. So if A and B are not equal, the rest of that thing won't even happen, right?
But it's still looking at like 4 as well equals to 8. So can 8 be not equal to 8?
So when you chain it, Basically, it's just checking that everything in there is like equal or not equal. So in this case, if A is equal to 4, it can't be equal to 8 anyway, right? It's not comparing 4 and 8, it's comparing 8 to 4 and 8.
So is it checking that they're all not equal? Is that what's gonna happen?
A is equal to B, and A is not equal to 4, A is not equal to A.
Basically, it pads an and for you.
Okay.
Because A is equal to B, so if A is not A, then B will not be A.
Okay.
So that's what.
Think about it this way, it kind of like pads in the and for you. When you write something like this, it's the same as saying A not equal to 4 and A not equal to 8, B not equal to 4, B not equal to 8.
So it looks like it's saying B, like 4 doesn't equal 8.
If you're hesitant, just use an and. But
I'm not gonna do this to you on the exam. That's a big beyond.
This is just a syntax thing. It's the same as writing out ands. Yeah, if you write A not equal to 4 and A not equal to 8, that's fine. It means the same thing.
That's what we're doing.
Yeah, I think you had a question.
Oh,
okay.
So you say and, and then it's like, okay, number 6, like, are we gonna be more of this, or are we gonna be that?
Yeah, don't worry about that. I'm not that evil.
Yeah. Okay, guys, we have to move on. There's just not enough time to like dwell for too long on this stuff.
Don't worry about that part.
Okay. Now we're gonna move on to strings. Just you guys, can you just settle down just a little, please? Okay, so recall that a string is just a sequence of characters. It's usually like a word or a phrase. And in Python, string literals are kind of double quotes or single quotes. It doesn't actually matter. So if I said my string is CSCA20 with single quotes, it's the exact same as writing it with double quotes. Okay. And back to strings. We're going to do this again. Which of these will run? Who says line 1 will run? Okay. Who says line 2 will run? Okay. Who says line 3 will run? Who says line 4 will run? Who says line 5 will run? Who says line 6 will run? Who says line 7 will run? And who says line 8 will run? You seem to think that everything will run, right?
I'm very I'll put my hand down for one of them.
Okay, which
I'm
one?
just writing down the code before it works. All my syntax is wrong right now.
Okay, so these are the ones that will run. 1, 3, 6, and 8. Line 1 will run because we're concatenating the string 4 with the string 0. Okay, so we'll get the string 40. Line 2 won't run because we have a string and an int. We can't add those together without converting the int into a string first. Line 3 will run because that is the repetition operator, multiply sign. So we'll actually see hello, hello, with no spaces in between. Line 4 will not run because we can't multiply a string with another string. It has to be int. Line 5, again, will not run because we can't add an int to a string without converting it into a string first. Line 6 will run because we're both strings. Line 7, again, you can't add a string and an int without converting one to the other first. And then line 8 will work because we're taking the int, converting it to a string, and then adding from the string. Any questions about that? Okay. So the take-home message here is, remember, if you're going to concatenate to a string, make sure what you're concatenating with is another string. And if you want to repeat a string like X amount of times, make sure that the number is actually integer, right? So you can't have a string 10 times if the 10 is a string. It has to be an integer. Good. So what we saw there was called string concatenation. And that's this kind of logic here. If we have a string first and a string second, then together, if we add them together, it returns first second. When the strings are added together with no spaces in between. So if you try to add words together, what do you have to add between those?
Sorry, space.
Yeah, a space. So if I wanted first space second, then I have to make sure I have a space after first before I add second. Or a space before second before after first, right? So that way it has a space in between. Okay, and then string indexing. Yes.
In this one, wouldn't 4 and -1 be the same index?
Wasn't it 4 and
Or a
negative
negative, in this one, because it's a 5, oh, no, you're going from,
So we're from hello.
oh, I was only looking at world. Okay.
Yeah.
My bad.
So again, when we index a string, we start counting from 0. So in this case, if you look at the H in hello world, that's index 0, the E is index 1, right? It's always offset by 1. So if my string is hello world, then my string index 4 will be the O, because you see 0, 1, 2, 3, 4, this is the O. Yes.
Sorry, so because your second index is -1, -1 is actually D. And you're supposed to end your slicing at the character before your second index, therefore it should be ORL.
True. That's another typo. Good, you're catching these things. And I'm screwing up. But yes, she's right about that. Okay, yes. So, just repeat that again for everyone to hear, please.
Oh, so because your second index designates when your slicing cuts off, but it cuts off at the character before your second index.
Right.
Your second index is D, so it should cut off at L.
Right. So she brought up a very good point, something that I screwed up here. When you index a string, the first index is included, but the second index is not included. Yes. Previous slide again. This guy.
Yeah, 4 to -1, it should get 0. No, sorry. O space W O R N.
Yeah, I used to know O as well. Sorry, this was really sleepy when I made this. Yeah, you're right. It's the second. It should be the first one, not the second one. Good catch. Really good catches.
It was a test, you passed.
It is O space W O R L.
That's what he just said.
Yes, I did. Okay.
That's, yeah. So good catch, yes. This should be from the second O, from the first O, not the second one. I guess I wasn't paying attention. And yes, the last index is not included. So it should be O space WORL, and I'll have it fixed before I post this. Okay, good. So if we're looking at the string again, CSCA20 is a lot of fun. If we index it up to 4, then we see CSCA, which is index 0, 1, 2, and 3, not the 4th thing itself. So I did get it here. Remember, the last index is not actually included. It goes up to, but not include the last index. But if you do something like this, for example, it takes the 4 onwards, whereas in this beginning index, so index 4 itself is included. So we see 20 is also fun. And, question?
Shouldn't it be is a lot of fun, not is lots of fun? Right?
Yes, a lot of fun?
Is it right?
There's no O in the original string.
What she said,
Okay.
yeah.
Okay. If we index it from 4 to 6, then we'll see indices 4 and 5, but not 6 itself. So we get 20. All right. Moving on. So again, back to this idea. When we index a string, the first index is included, but the second one is not included. Right? All right. This time, if I index the word computers up to the index 4, what do I expect to see? I'll keep you a minute to look at it. All right, who says A? Who says B? Who says C? And who says D? All right, so the correct answer was C.
Yeah.
Because we're indexing it from 0 to the index 3. So 0, 1, 2, 3, we get comma. Okay, what about this one? My string at -1. What does this give me? Who says A? Good. Who says B? Who says C? And who says D? None of the above. Okay, good. So it was S. So just the very last name string. Yes.
Would -2 give you R is not working with that?
Sorry?
Would my string index -2 give you
It
R?
goes around even.
Sorry.
The answer is yes.
Yes.
Yeah.
So it goes, okay, gotcha.
So this is like indexing backwards. Okay, what about this one? If I say, what is my string up to 300, what do I get? Who says A? Who says B? Who says C? And who says D? Good, so the correct answer was actually B. Because if you go past the index, it's also not indexing it at some location, it won't crash and steal the entire string. Good. Now what if I do this? What if I say my string at index 12? What does this give me? Who says A? Who says B? Who says C? And who says D? All right, good. D's the right answer. Okay, and if you tell me what will happen if I try running this. Yes. Perfect.
Are you just running it? Oh, okay, all right. It's fine, yeah.
Can you explain then why, to prove you're not running it, can you explain why it's in that range?
Because computers has range up to 10. So if you're at index 12, you can't run at 12 because it makes numbers 10.
Good. Right, so for those of you that didn't hear, if you index at something past actual length of it, then you're gonna get an error. All right, so if my string is computers,
So, oh, it's me. Alright. So you can only index from its length to the negative of its length.
yeah, more or less. You can't, like, if I index this at like 3,000 or something, it's giving me errors because I don't have a 3,000 character.
If I did minus 12, that's not right. That's also same issue.
Yes.
Yes.
Okay.
Index 10, but there's only 9
9.
characters.
So, so sorry, if you index, whatever, like, the actually count it. But basically, when you index a string, index it to its very last index that's available, either forwards or backwards, but you can't exceed it.
If you just put colon, like that will look like that.
Just a colon, the other one.
Yeah.
All right, what if I do this? If I index a string from index 5 onwards, what do I see? Who says A? Who says B? Who says C? And who says D? Good. So it's TERS, which is indices 5, 6, 7, 8. All right, here's a trick question. What if I index it from 6 to 6? What do I get? Who says A? Who says B? Who says C? And who says D? Okay, so the correct.
Can we see B? Can we see B again? And can we see C? Okay. Nice.
Pretty interesting.
Yeah.
So the correct answer was C. Can anyone tell me why?
Yeah, but it should include 6. Oh, but stop on before 6.
Right, so that's right. Another way of thinking about it is if you're including something that's both in and not in, you're not really indexing the string. So if the indices are the same, it's going to be in the string. Good. Now, what if I change it to 6 to 7? Right, so in this case, we'll see E, right? Because we're not actually indexing a single character in the string. All right, what if I run this? What is the length of the string? Yes, 9.
It's
Sorry.
okay, this class isn't about counting, you're fine.
Yes, so the correct answer is 9. But given the length of a string, how many indices does it have? Well, how about generically? Length minus 1. So the number of indices in a string is always length minus 1. Because you count from 0, right?
That's not quite right. If you want to talk about the number of indices.
Sorry, the maximum
Yeah,
index.
okay.
The maximum index.
Yeah.
There are 9 indices. We count 0, 1, 2, 3, 4, 5, 6, 7, 8. But the maximum index is length minus 1. Good, correct. Okay, so what is the length of my string from 6 to 6? 0, right? Anyone tell me why? Right, so length of the empty string is only 0. So now we're combining some concepts. What is the length of my string from 5 to the end? Who says A? Who says B? Who says C? And who says D? So the answer is B. And yeah, seems like most of you get it. So now we're going to move on and talk about loops. First, let's start with for loops. And a for loop works like this. So we have for something in something, we perform some operation, right? And generally we want to do for some element in some collection, we perform some task, right? So in this case, a for loop will iterate over the collection one element at a time and perform a specified operation. And there's two types of for loops to talk about in class. One is an index for loop and one is the elemental for loop. So if I do for a character in some string, we call that an elemental for loop because it will loop through the elements in that string, each being a character. But then we also do index for loops. So for I range length of the string, we loop through the string by index and then reference the string at that index per character. They're both equivalent, but at the end of the day, they're both looping through some collection. Because for index for loop, even though we're looking by index, that index is a collection of the indices of the string, right? So if we do range length of a string that has 4 characters, it'll be 0, 1, 2, 3. So basically same for I in 0, 1, 2, 3, I equal 0, I equal 1, I equal 2, I equal 3, so on. So again, for loop is always going to be for some element in some collection, do something. So here's some examples. For num in range 4, print num. In this case, it'll be 0, 1, 2, and 3, right? And then if you do something like this, for num in range length of high, print num. You know the length of high resolved to 2. So it's the same as saying for num in range 2. So we'll have 0 and 1. And now we give you some time to look at this program. This is something we call tracing. It's basically looking at a program and knowing what it returns. In this case, we start at result equals 1, and then we say for num in range 3, we're adding num to result, and then we're printing num and result. Can anyone tell me how many times this will run? How many times the loop will run? Yes. Why?
0, 1, 2.
Perfect. So 0, 1, and 2, these numbers he said. What value is that, num or result? No. Okay, so we know the result starts at 1. So given the values of num that we have on each iteration, we know that num is 0 on the first iteration, num is 1 on the second iteration, and num is 2 on the third iteration. What do we expect the result to be on each iteration? Anyone? Yes?
How come you only do 3 iterations, not 4? Isn't it 0, 1, 2, 3, 4? I mean 0, 1, 2, 3.
That is 3 iterations, all right? 0, 1, 2, 3. 0, 1, 2. So it's 0, 1, 2. It wouldn't be 3 because remember range doesn't include the last one again, right? So remember the first time for num in range 4, we have 4 things coming out of it. 0, 1, 2, and 3, but not 4 itself. And in this case, we're going up to 3, so we see 0, 1, and 2, but not 3. Because if you do 4, it's actually 4, even though it's in range 3. That was just coming at 0, right? Okay, so has anyone figured out what num and result are on all 3 iterations? Yes.
First iteration, num 0, result 1.
Mm-hmm.
Second iteration, num 1, result 2.
Mm-hmm.
And third iteration, num 2, and result 4.
Perfect. Can you explain why result is 4 on the last iteration, not 3?
Plus, it's adding.
Right, so it's adding num to what the previous value result was. So the first time down, num was 0, and result is 1, because we said that's 1 to begin with. Second time, we're taking num and result and adding them together. So now result is 1, and num is 1. And then we're adding num and result again. So 2 plus 2 is 4. So result is 4, and num is 2. Any questions about that? Okay. So moving on now to while loops. While loops are a little bit more different, And we have something called a loop condition, which basically says, while something is true, we keep looping. So as long as the condition in that blank holds, the loop will keep running. As soon as that condition becomes false, or you break out the loop, or with either return or break, the loop will end. Any questions about that? No? Perfect. So look at the same code again. We can translate the two pieces of code we had earlier with the for loop into a while loop. So we can do num equals 0 while num is less than 4, which is the same as say for I in range 4. We do num and then we increment num every single time. So it keeps going and eventually ends. But can anyone tell me what will happen if I don't have line number 4? What happens if I don't increment num? Yes.
Oh, it'll just print 0 each row.
It'll what, sorry?
It'll just print 0.
Exactly. Do you know what we call that?
Infinite.
Right. So if I don't increment num, then num will always be 0, and 0 is always less than 4, so we'll just keep printing zeros forever in infinite loop. So we need to have that num plus equals 1 to make sure that num actually goes up every time, so the loop eventually ends, right? Good. So again, like we saw earlier, this will print 0, 1, 2, 3. And then our second one is the same as the for loop we saw earlier. Result equals 1, num equals 0. That's where we start off. While num is less than 3, we add num to result, and then we print the two values, and then we increment num at the end. And again, this will give us num 0, result 1, num 1, result 2, num 2, result 4. Any questions about that? Yes? Because it's printing it, right? So print takes, I want to print out the string, but before I can add it to the num, I have to convert it into a string, so I can add it to the string I had earlier. Sorry?
Is it necessary to convert it to string?
Yes, because remember from the slides earlier, you can't concatenate an int and a string without converting between the two first, right? So that's applying previous knowledge into this as well.
It also depends on what version of print or how many arguments you want to give print, right? Because a lot of times in lecture when I printed more than one thing, I printed them as separate arguments, right? So I added a comma between the string and the number, for example. Yeah, so that's what I did in lecture, but Autumn's trying to print just the string. Yeah.
All right. So the take-home message from this is for loops and while loops are equivalent. Given enough know-how, everything you do with the for loop, you do with the while loop. Everything you do with the while loop, you do with the for loop.
You can't make an infinite loop with the for loop.
That's true.
Yeah, but anything else, yeah.
Yes.
What if you do range, if you put in math and then you did range to infinity?
I think that's not going to work because infinity is a float, and you have to give it integer when you're doing range. Yeah. But nice try.
Nice try. Okay. And now moving on to the list. We're blazing through this stuff pretty quick just because there's only so much time. Again, a list is an ordered collection of objects, but they don't have the same type. So for example, we can have a list of true 3, the string Bob, and the float 2.39. We can have all strings, so Sarah, Anna, Karen. We can have all numbers, 2, 4, and 64, 264, and so forth, right? And again, we can index and slice a string, a list the way we do with strings. So if my list was true, 3, Bob, and 2.39, then my string up to 2 would be indices 0 to 1. So a list of true and 3. Yeah. And similarly, we can concatenate two lists, although we call it appending. Concatenate is right, not appending. We can concatenate two lists using the plus operator. So if we have a list of row names, so we have Sarah, Anna, and Karen, and a list of boy names, Billy and John, then you can add the two and have Sarah, Anna, Karen, Billy, John. Okay? So it's the same as what we would see with string. There's also the repeat operator, like we saw with strings for lists. So if we do a list of Sarah, just Sarah, multiplied by 3, then we see Sarah, Sarah, Sarah. And you can check for membership within a list using the in keyword. So if we say Sarah in that list, it will return true. If I said John in that list, it would be false because you don't see John in your list. Does that make sense? Perfect. And so after seeing all of this, you notice that strings and lists are pretty similar in that they're both ordered collections. A string is technically an array of characters, and a list is an array of objects. So every time you iterate through a string, like let's see hello world, first would be age, and then E, and then L, and then L, and then O, and then the space, and then world, like that. And then with lists, when we iterate through, we see hello and 3.14, true, and so forth. So it's always a collection that you go through item by item. So when you loop through them elementally, most of the things you get separately on each iteration. Good. And then there's helpful string functions that you can use on the final exam, and you probably use these in the labs and exercises, and hopefully in your assignments. You have these. So CMP takes two lists and compares them. Min list returns the minimum item in the list. Max returns the max. Length of the list is kind of the length of the string, returns the number of items in the list. Yes. One of you. It compares the two. It compares the list.
What's the comparison? So it tells you if they're equal to each other?
I can't remember.
It's, I think if they're equal, I think CMP will return 0 if,
Oh, right, yeah, it gives you the difference between the lists.
just don't worry about that one. It's a legacy, or it's a relic from an older era of programming.
Yeah, it's like C star column.
Yeah, exactly.
Don't worry.
Yeah, don't worry about it.
So remember, actually, I'll explain it since we're at. Remember the Levenstein distance thing that you had for I think it's A2, A3? It's like that for lists, basically.
Oh.
Yeah, you shouldn't need to use it, but
I thought it was like a comparison like greater than or equal to, is it not?
no, it's like a different. It's like star competency.
Yeah, that's an alphabetic comparison, like a dictionary order comparison. Like, if one comes before the other, then it's less than, and if one comes after the other, it's greater than.
It returns integer
Okay.
difference too. It's a negative and positive.
Alright.
Yeah, don't worry so much about this one.
Yeah.
When I try to run it, it says names, CMP is not defined.
Yeah, CMP is not there.
Yeah.
These are methods, right? No, they are.
Even
They're functions.
methods are not there.
Yeah.
Oh, CMP is not there.
It
Okay.
might be type of 2.7 thing. I don't know. Just don't worry about this one.
Don't worry.
Okay, well, these are the ones that you really like. Just worry about these ones. These are the methods. So list out append, we'll add an object to the end of the list. List out count object, we'll count the number of times the object appears in the list. List out index object, tells you where it appears in the list, where it first appears in the list, right? And then list out insert index objects, inserts the object at that index. Yes.
So what's the difference between append and extend? Like,
Extend.
yeah.
What's extend?
Okay, so extend. Okay, let's do append first. So append takes one thing and sticks it onto the end of your list. Extend takes a collection, like a string or a list or dictionary or whatever, and sticks it onto the end, like sticks the whole collection onto the end.
So like you use append for one thing and extend for a list.
Yes, exactly.
If you want to combine two lists, one list.
Also, it merges into the end of the
Yeah.
original list.
Yeah.
Okay.
So merging two lists instead of adding new lists.
Yes.
in a list.
Yes.
Okay.
You get a question?
This stuff is given on the exam, right? Like dot insert dot.
Yeah, I'll be providing documentation for everything you need.
Yes.
Can you go over one more that I'm not so sure about how? Oh, it was on the next slide?
Pop?
Yes.
Yeah, so pop just removes and returns the last object from the list.
Okay, now there's one thing about this pop that I'm not sure if it's returning the element that was popped or it's returning the list.
It returns the object removed. So let's say my list is 1, 2, and 3, and I go with pop, it'll remove the 3 and return 2.
But does it modify the value of the list?
It modifies the list.
So two things are changing.
It changes one thing. It takes the last element out of the list, so your list becomes shorter, and then the thing it takes out, it gives to you.
Okay.
Yeah. It's similar to list remove. Remove just removes the object. It removes the object you gave it, but doesn't return to you. It just pulls it out. Yes.
If you print list dot pop against something, will you get the item that's removed? Or
Print, let's say your list is less than 1, 2, and 3, and if you print list.pop, it'll print 3.
oh, so it's not gonna print the new list.
It's not print the new list, just the thing that. So the return value is what it prints, right? And the return value for this is something that popped from the list. Yes.
It removes the last item or it removes the item at the index?
List.pop has no arguments, right? So it's just the last item.
I think it might have an optional argument.
the ways we used it in the past is we gave it an thing and say get rid of the one and this.
Yeah.
Yeah, so that's an optional argument. If you call it no arguments, just use the last thing. Because like usually when you use it, use like a stack. I'm not sure if you know what that is. It just moves like the top thing. Don't worry about it so much. You give an optional argument, and you give the optional argument, it pops that item. If you don't, it pops the last thing by default. Thanks.
Reverse equals true, will it pop first type?
I'm not sure if it has a reverse. You can look that up, but
Because it's left off like that.
really, if you just want to get the first item or last item without actually removing it, you can always just do, like list at index 0 or list at index like -1. Okay, moving on, list our reverse. We'll flip the list. So the first item becomes the last item, the last item becomes the first item, and so forth. And again, really quick recap, when you're iterating through a list, if every box represents something in the list, and they say for I in my list, then I is every single one of these boxes until the end. Yes.
Is there a way that you can return a list with where if you're like returning it or you're printing it, you have the extra argument reverse equals true, and then that kind of does the reverse function?
What do you mean?
So a couple times in the assignment I've seen like the
You
argument.
do like list.sort reverse equals true.
So the sort type thing.
Right, because sort sorts it from least to greatest, but if you said reverse equals true, sorts from greatest to least.
So doing sort with reverse equals true is the same thing as dot reverse? Or with
Well, it's
reverse?
the same as saying list.sort, list.reverse, right?
Okay.
Because if you sort it from least to greatest and reverse it, it's the same as like sorting it the other way.
Reverse doesn't sort it, it just takes whatever the order it's currently in and then reverses that.
Right.
Okay.
Okay, so now I'm from the dictionaries. I know this is really fast, but you have to do everything, so bear with me.
You can take your time.
Okay.
It's fine.
I just want to make sure you have enough time to like go through some.
It's fine.
Okay. So a dictionary is a set of key value pairs. So where we have a bunch of keys, and each key points to a value. So a dictionary is unordered, mutable, and indexed. So it's a little bit different from a list, because once you define the order for a list, the order stays the same. With a dictionary, that's not true. So just because you added a key later to the dictionary doesn't mean it comes later in the dictionary. The order is random. So you can't say my dictionary at index 4 because the indices keep changing. So if you want to index it, you have to index it using a key, and using the key grabs you the value. Okay? So think about it as like a bunch of closed doors on one of those like airport things that spins around. You can't grab at some like index because it keeps moving. But if you have a key to one of the doors, you open it up and get the inside of it. Okay, and they're mutable and unordered. Covered that. Mutable just means you can change it. You can add things, you can remove things, and you can change key value pairs. You can reassign new values to keys. You can get rid of key value pairs, add key value pairs. And we can actually think about a dictionary as kind of like a table. Where in this case, I put my own information in. You can think about the key as, like the table columns, and then the value as being the item in that column. So for example, I can have my name, so that's my first name, Carl, my age, says 19, occupation, TA, program, CS. And so if I grab my dict at occupation, I'll get a TA, right? So when we set up a dictionary, we know that we can follow our instincts. We know with a new string, we just give it empty quotes because the string needs quotes. With an empty list, we can give it empty brackets because quotes go in brackets. Well, the dictionary have curly braces, so we can give it empty curly braces, or we can use a constructor, which is DICT open bracket close bracket. They're equivalent, either works. Okay, any questions about that? No? Personally, I prefer using the constructor just because we have empty brackets. It can also be a set, but it doesn't matter. Okay, so adding values to a dictionary. If we're adding a new value, it's the syntax. My dict at the new key equals the new value, right? So we have to specify a key value pair. We can't add a value with no key. We can't add a key with no value. We technically padding none, but like, it doesn't really make sense to do that. So my dictionary at some key is some value. So for example, if I'm creating this dictionary, I can do Kara equals new dictionary, and then add a name to my name, age to my age, and job to TA, right? So all of that will give me this dictionary here. Yes.
Instead of putting car equals dict, try, you can just put two code.
Yeah. As I said earlier, they're equivalent. Okay. So reading values from a dictionary, the syntax would, yes.
Why would you like print and then dict with markers like print out?
It would print an empty dictionary.
Oh, after you use like, so the last one would be this. So after you said all that, would everything print out that whole thing?
Yeah, well, it'll print this dictionary, but the order may not be the same. So in this case, I see name, age, and job. If you print it, you might see job, age, name, or job, name, age, or whatever. The keys and values always the same key will always have the same value, but the order they show up is pretty much random. Okay. And then reading values from a dictionary, the syntax is very similar, except we flip it. So the value we get is my dictionary at some key, right? So for example, if I want my name, then I can reference my dictionary, which is named Kara, at the key name, and that'll give me the string Kara. Right? But if I try doing something that doesn't actually exist, if I try referencing it at address, then I'll get an error because I don't have a key called address. Does that make sense? So it's kind of like indexing a list or a string, and I try to give it some valid index, but in this case, instead of the index being a number, it's going to be a key. And the key has to exist in your dictionary first. Okay? So, if we want to remove values from a dictionary, we can do my dict.pop key. And for example, if I had the same dictionary earlier, if I pop job, then I'll just see name and age. So popping removes the key value pair, not just the key or not just the value, it's the entire key value pair. Any questions about that?
Doesn't pop remove the last thing and before you return?
So remember that dictionary is unordered, right? So there is no like last thing. You have to specify what you want to pop.
So when you pop job, does it return job?
Sorry?
I think it does.
It does. But notice I didn't save the variable anywhere, right? I didn't say something equals my dict.pop because I didn't save it to a variable, it's kind of just gone.
So you said char.pop job, right?
Yeah.
But it returned your name and age.
No, I'm saying that the dictionary will look at that afterwards. That's why I use an arrow. No,
Gotcha.
right, so after I pop job, a dictionary will look like that, but it doesn't actually return the dictionary.
Just a question. So if you take char.pop job,
It will give me job colon. Yeah. All right, so we can also update key value pairs.
Oh, that is a question.
Right? Oh, yes.
So if you pop the key, you drop the value as well.
So for pop, you reference it by a key. So you're saying, I want to pop the key value pair with the key job, but it takes out the entire key value pair. Because remember, it's like I said earlier, you can't have just the value with no key. So when you pop the key, it takes out the entire key value pair.
Yes.
Yeah. You can't. It has to be a key. Now, if you want to change the value though, that's where update comes in. So you can keep the key but change the value. So you can do my.update key and new value. If you want to keep the key but get rid of the value, you can actually set new value to none. In that case, we'll have the key with none as the value. Yes. Yeah, so in this case, if I do car.pop job, then if I save this variable somewhere, in this case I didn't, but if I did, I printed that, then I would see job TA being returned to me from the pop.
Okay, but also like the new phrase.
New phrase?
Like will return this without it at the end.
The dictionary? No. So the reason I have this here is just to show you what it looks like afterwards, but it doesn't return the dictionary, only if they get popped. Yes.
So the value you return the job TA is a date value.
It's a key value pair, it's like a tuple.
But
Yeah. So back to up,
Yeah.
yes.
I just had a question about update. Can't you do the same thing by writing minded bracket key equals new value, and won't that override the key you have and override the value you have for that key with the new one?
You can override it as well, but what if you want to like just remove it completely? Right, so pop will actually, so might need to up this return anything to you. It just updates it. And in this case, if I want to replace a key, I can definitely use update to replace a key and value pair. But if I just wanted to like get rid of it and see what I got rid of, then pop's nothing to use. Does that make sense?
Something doesn't look quite right. I think, like, is that even Python syntax to have a colon in the, like, in the arguments for is that supposed to be a comma?
That should be a comma.
Oh, okay.
Sorry, yeah. So that should be a comma. It should be dictionary.update key, comma, new value. So basically, it takes the key, and then assigns a new value to it. So yeah, that should be a comma. He's right. In this case, if I do car to update age 300, it'll replace 19 with 300. Assuming it's that long, I will, but not with the shot anyway. Okay, so this is an important dictionary methods. You guys probably should have seen by now. So dictionary.copy returns a copy of the dictionary. Dictionary.clear gets rid of everything from it, gets rid of all the key value pairs, and essentially makes an empty dictionary. Dictionary.keys returns a list of all the keys. Dictionary.values returns a list of all the values. Yes.
What if you have like repeat values?
Repeat values?
If you have keys with the same value.
It'll show up. They're not unique.
Oh yeah, that's right. The values are not unique. The keys
are unique.
Yeah.
Yes, but if you have a key if you have several keys with the same value, will you get a list of the same values repeating, or will you get one?
You will.
Multiple.
So let's say we have A to Bob, B to Bob, and C to Bob. If I do keys, it always just be A, B, C. If I get values, it'll be Bob, Bob, Bob.
Okay.
Good question.
If we assign variables to dictionary.copy, and then we change up the dictionary name, and then we return that variable, it'll return a copied dictionary, right?
No, so dig.copy will keep you copying the original stuff now. So it won't modify your original dictionary. So if you change the copy, it won't change the original what you copied from.
I mean, like if you assign a variable to dictionary.copy early on, and then you change the dictionary later on.
It won't change the copy. The copy is like a snapshot of what it'll type at the moment. It's like saying you have a twin, right? You guys are identical twins. It's like no, if you were, you guys are copies of each other, right? So you're identical upward. Let's say one of you goes and gets a tattoo. Does the other one not get a tattoo? No, right? Same kind of thing. Yes. I'm sorry?
What kind of scenarios would we use these dictionary?
That's a very good question. So think about this. Remember for your Pokemon stats thing? One of the ones was the keys are names,
I think
right?
so, yeah.
And the values were what the values were?
Like tuples of stats and stuff.
Yeah. So if you want to get the stats for every single Pokemon, you can go for some tuple in dictionary.values and they'll give you that. But then if you want just all the names, then it'd be dictionary.keys would be the names of all Pokemon. So it's sorry? You don't always need them together, right? Because sometimes you want just all the keys or just all the values, and that's just the quick way of getting through it. Sorry? I don't know what you're asking.
It's not going to permanently separate them, only for the purposes of.
It doesn't.
Yeah.
So this doesn't modify the dictionary in any way. That's what you're asking. It just returns a list of all the keys and all the values, but the dictionary doesn't change. So if you want them together, you can still access your original dictionary later. It will make a difference. Yes. Can you update a key and not a value? That would just be adding a new key to the dictionary, wouldn't it? If you want to change the name, well, you would just be adding a new key with the same value.
And then deleting the old.
Yeah. Yes.
Is there any way to have a key be assigned like multiple values, or would it just always
Yeah,
have
so
two?
if your value is a list of multiple things,
Yeah,
then you can actually have a key
but
and
it's
then a list.
technically
of
one list. It's one list.
It's technically only one value per key,
Yeah.
but if your value is a collection, you have multiple things in that collection. So you can actually set a dictionary as the value for a key, even. Good question.
But no.
Question? Yeah.
Where? Yes.
What if, like, for one key, you want more than one value?
Well, he just asked that, right?
Why was it the same?
So if you want more than one value for a key, you can set up a list as the value. And then, like you just Pokemon stats, right? One of them was the key was the type, and then the value was a list of all Pokemon going to that type. Something like that. Yep. If you guys have questions, if you don't mind putting your hand up just a little bit higher so I can see them. Yes.
So the dictionary.update.
Update.
So it doesn't work with comma or semicolon, like with the quote. It doesn't work.
Yeah, it should be a comma.
No, it doesn't work with comma.
I think, okay, so I figured it out. So what it actually does is kind of like the extend operation for the list list. And it basically adds whatever, if that's a dictionary, it adds that to that dictionary.
So it combines two dictionaries, basically.
Yeah.
So yeah, it's more like extend than it is like append or. Yeah.
So you would have the dictionary brackets inside, and you have the key, and you balance it there.
Interesting. I'll look into that and I'll change it for when it goes to this. That's interesting. Okay, back to this. We can always use these things with dictionaries as well. There's in, so we can check to see if the key value pair is in our dictionary. We can check the length of our dictionaries, how many items are in it, and that'll come the key value pairs, which is essentially just the number of keys in our dictionary. Type, so we can check types of keys and types of values. And then there's the keyword del. Don't worry about that one. That kind of just, it clears the value of a variable. Don't worry about that. If you're using it at all, it'll start to break the dictionary. Don't use that. And so we can combine some of these methods together and do something like this. So we do sorted dict.keys. Then we're trying to sort a list of keys. Sorted dict.getKey. If the value is a list, then we get a sorted list of values from that key. We can do type of dict.getKey, so we get the type of the key. Type of the value from that. Sorry. Yes.
Question. Did you teach .get?
I think I recommended the usage of it in tutorials. So technically it was part of this curriculum.
So .get is actually the same as reading values, right? So if we do my dict at some key, it's the same as saying my dict.get key. Right, so instead of using square brackets, we just .get instead. It means the same thing. It'll return value as that key. Okay, and now we're going to focus on, yes.
One general question, like, it's not interesting if you put on the older function and then everything has to be measured, or we have to go online.
So you'll be given like you said, you'll be given a list of the ones you need for your exam. I'm just going over the. Sorry?
There's no explanation.
There will be.
There will be. I'm just going through this really quick so you know like when to look what.
Is there a way to check if value is present in the dictionary?
Yeah, so you can do if something in my dict.values.
Just for the keys, we can use that for the value.
So remember that dictionary.values has all the values, right? So if you want to see if a certain value is in the dictionary, you can get a list of all the values and check to see if it's in that list, right? Which is why I recommend dictionary.values.
Yeah, like this.
Oh. Okay, and again, looking through a dictionary. So we're used to seeing that for I in something syntax. Remember for I in dictionary, it points to all the keys, right? Unless we're looking to like tuple for A and B, for key and value, we'll get both. But if we're doing just this, we're looking through only the keys. So then if we're doing for I in dictionary at I will give you the value that I points to. So notice the pink arrow, where I'm looking through, it points to only the keys. It's up to you to get the value from that key, using either .get or square brackets. And then moving on to files. The way you were taught to use files in class was using the with block. So with open some file as subname, you can call it My file, you can call it F, you can call it Bob Dylan if you want. Some of you have wondered about that. It doesn't matter what you call your variable, as long as it's an open file, it'll work. But do not confuse the file name with the open file handle, right? So it's usually with open file name as F. If you don't actually have that open block and you're just using file name, it won't work because file name itself is a string. So you have to actually open it and get open file to work with. Yeah, everyone remember that? Okay. So we open a file using its name, but that file has it in the same directory, aka the same folder that Python code is in. And then you can store that open file into a variable, and then do something with it within this with block. And as long as you're in the block and the file is open, as soon as you exit the with block, the file closes automatically. So if you try referencing the file again outside this with block later on, you have to open it again. Make sense?
Let's use open, right? Then you have to close.
Yeah. So now to get onto her point, if we use open like this, then you can do my file equals open file, but then this will close automatically for you. You have to close and you say file.close. Okay. So this is what I call the manual way of doing it. So again, it is the same thing. It'll store the open file into my file, and it'll open the file name that should pass into the argument file. And then one thing to remember is there's also a mode bit. So for mode, you can set this to R, W, or A. R is read, which means we can read the contents of the file, but we can't add anything to the file. Write clears the entire file first, and then writes into the file as a blank file. Append keeps the file's contents, and then adds onto it. Okay. So if you're just looking to read through, let's say, a CSV file, then you probably want to open it for reading because you don't want to clear it. If you want to override a document, then write will basically replace it and can rewrite into it. Append is that if you want to keep adding to something later on, use append. Any questions about those? Yes.
And we can use all of this, like R, W, A, with the with open statement, right?
Yeah, so there's two arguments it takes. File, which is your file name, and then the mode, which is how you want to work with the file. So either read, write, or append as a string.
How do you create a new file? Like, do you always have to just clear an old file to make a new file?
No, so if you actually open a file with a name that doesn't exist, they'll create a new file for you.
Okay, so then what's the point of having to write over just one name?
So sometimes you want to clear a file after in your program, and like if you want to clear what's already there, in case there's something there already, you'll use write. So remember how before SQL you have that drop table that exists, I think? Same logic as that. Yes.
Is there ever a time we want to use that where we're doing a with open as F or file? What would be the advantages of the other?
I'm using what, sorry?
Instead of doing a with statement to open up our files, why would we, like, what would be the advantage of using my file equals over with open? Why would we?
It doesn't really make that much of a difference. It comes down to personal preference, right?
I think there was one situation in which I've ever needed to use the bad version, the one where you do it manually. It was a situation in which I wanted to keep a list of files, so I couldn't and I didn't know in advance which files I would want to keep. So I would actually open them all manually, store them all in a list, and then write to each one as I went, and then afterwards close everything. However, that was a bit of a tricky situation, and that was the only time I've ever needed it. So
for the exam, do we have to know how to use it as my file being the variable, or you could be fine with open statements?
Either one's fine,
Yeah.
as long as you remember to close it if you use the manual one.
Okay.
Yeah.
So for all purposes of this course, it's the same thing.
Yeah.
And it's probably easier to use with open,
Okay.
just because remember.
So that should be fine to get us through the exam per
Yes.
se, just with.
Just the with, yeah.
So RWA, like, how would it work in mode?
Yes.
Yeah, so those go into the mode. So we indicate what we want to do with it, either with string R, string W, with string A.
But after this, we want to close the file?
Right, so use open without the, so we have a with block here. If we're using the with block, we indent all the stuff we want to do with the file, right? Within that indented block, the file is open, and then past the indented block, so outside the with, it automatically closes. But if we're doing it without the with block, we have to remember to close it manually when we're done with it.
Close manually, or do we have to close it?
You close it manually, which means you have to close it.
Yeah. And for this, we're done with the with statement.
With the width block, it closes automatically. Well, you want to return it before you want to close file before you return. But if you have to return within a width block, it closes it before it returns automatically. But if you're using it manually, you have to remember to close the file before you return.
If we open a file without giving it its mode, it's automatically in read, right?
Yes.
So there's no situation that we'd ever have to really specify R. We just don't include anything.
Pretty much.
Yeah.
Yeah, it doesn't hurt to specify just so you know, but it defaults to read.
If you remember the pickle stuff, you had to specify R when you open in binary mode, but that's it. Yeah.
Okay, so again, if you open it without the width block, then remember to close it using file.close. But if you want this to work properly, make sure it's actually open before you close it. If you try closing a file that isn't already open, so if you try closing it on a string, like file name.close, it won't work because a string doesn't have a close method, right? So you have to call it an open file. And for anyone that's wondering why we should close a file, it's like why you should have your computer, so just turn the power cord. Well, first of all, you shouldn't do that, but like also we don't want conflicts with our applications that might use the file later. So if you keep a file open, things can happen, mess up like inputs going into that file. And then you don't want to hog more memory than you need to. It's kind of like clicking eject when we're pulling a flash drive as well. So just remember, if you're using the manual open, you want to close the file. If you're using the width block, don't worry about it. Yes.
I think you just mentioned pickle. Do you mind repeating what it is exactly how it relates?
Okay, basically when you were saving an object in pickle, okay, if you were using pickle to load something that you had already saved, you had to open the file in read binary mode. So you cannot omit the R if you were opening a file in pickle. Okay, so that's only for the pickle. That's not for like the regular text files that you see. Yeah.
How do you save pickle again?
You had to open it in WB, right, binary. Yeah.
WB.
Yeah.
And for those of you that are wondering what's better, if you use the width block, don't have to worry about closing files. And if your code causes an error, the file will close automatically. Whereas these things don't happen if you do it manually. And then the only thing that might potentially prevent you from using it is if you remember to indent the block. Whereas you don't need that if you do it manually, but let's be honest, it's so much easier to use the width block. So do that for your final exam. You'll save yourself a lot of like heartache and trouble. Right. And then we move to a file. So a lot of you have seen this before. You go for something in my file. This something will be a line in your open file. So if I go for line in file, it'll read the file line by line, right? And then if I'm going to process that line, you can remember to strip it. So that removes a new line character and any like beginning white spaces. You can also use .strip.split, and that'll split it into a list. But one thing I want to make clear is that if you don't need to split it, don't split it. In the case of the CSV file, it makes sense to split it because it's comma separated. You want to look at the values individually. But if you're reading through like, a novel using this, you don't really want to split because it'll split like word by word. And that doesn't really make any sense, right? So don't use .strip.split just because you used it a lot before. Understand what they're doing and only use them when you actually need to use them. Does that make sense? Okay. There's some other file methods. So there's file.readline, which reads the next unread line of the file. And there's also kind of a tracker for this, which keeps track of where you've already read. So you've seen this in skip header. By calling file.readline as many times as there are lines in the header, you can skip ahead of your other functions, right? File.readlines returns a list containing all lines of the file. Don't recommend using this usually, unless it's like a very, very short file. You shouldn't need it. File.write something. It's kind of like print, except to print into your file. So let's say if I do file.write hello world, it'll write hello world into the file. But in order for this to work, you have to make sure the file is either open for writing or pending. So if you do file.write on a file that's only open for reading, it won't do anything. Does that make sense?
Now, one thing to keep in mind is that write will not add the new line character at the end for you. So if you're trying to write a line out, you need to add the new line character. Yeah.
Any questions about that? Yes.
You need to open a file as write or append to use the write function, right? You can't use
Yeah.
it if you open it as read.
I literally just said that, but
Oh,
yes.
sorry.
Yeah, no worries. Yeah, so to clarify once again, in order for write to actually do anything, you have to actually open the file for appending or for writing. So you have the permissions to do that.
With the file write, you're adding new lines to your file, right?
Right, so if I write hello world with no new line, it'll write hello world on this line. And then if I write something like CSCA20 is fun, it'll write it right after with no new line. So if I want this to be a new line, I have to write hello world new line character, so /n, and then write over next to the next line. So you have to manually specify where you want the new line to be.
Okay, if you're doing an append, right? So and you say a file.write text, you're adding that text to the last line, right?
The next available line from the file.
Not to an empty line, right?
What do you
I
mean?
don't know if you know.
So like if I have a bunch of stuff in the file already for append, if I write, it'll show up here.
Okay. And
It won't show up here.
okay, and if you want to write something else, it'll show up later.
Well, if I write something else, let's say the thing I write is only this long, this is this long. If I call write again without a new line, it'll write here.
Oh, yeah.
But if I do /n, the next time I write, it'll be here.
Because the other lines, they all only have that backslash.
Well, if a line ends, so basically every time you press return on your keyboard, it asks me line character, right?
Yeah.
So everywhere when you want to press return, you have to add /n.
Okay.
And then what type of file you guys have been working with quite a bit is CSV files. And again, CSV stands for comma separated values. It's basically translation of a table into text. So programs like MS Excel, Apple's Numbers, or any spreadsheet program have the option to convert your table into a CSV file. So all the values in the columns be separated by commas. So in this case, if I have a CSV file like this, the pink we see there is the header, right? So you see the column names, you see name, age, and gender. And then each entry, so an entry for Linda, an entry for John, those will be the values in here. So we'll see the first line of our CSV file will be name, age, gender, each separated by commas. And then Linda 34F, that's the next line, that's the first row. And the second row will be Joseph 8M, right? So if I'm reading through the CSV file here, how do I get each row into the list? How do I get each row into the list? Anyone tell me? Yes.
I never really guess, but for line in file, line not strip dot split.
Yeah. Why? Because for line and file, we'll read each line. So the first time I read it, it'll be name, age, gender. And then the second time I read it, it'll be Linda 34F. But in each of these cases, you want to strip it, so remove the /n from the end of it. And then you want to split it. But you are actually missing one thing, very close though. You want to split it at the comma. Right? So remember the split, you set parameter in, where like what you want to split it at. In this case, the CSV file, we know it's separated by comma, so you want to separate it at that comma. So in a lot of your exercises and assignments had, let's say, a variable called sep, which was whatever things were separated by. You want to split by that.
In the brackets, you just put the comma, or do you have to put the comma in a string?
Yeah, so it would be a string because you're separating at that string. So it would be dot split. Right? Yes.
And so what that will give us is 3 lists.
Well, it's actually one list on every iteration of the loop, right? So your list changes when you're doing for I in for line and file. So the first time you loop, your list will be name, age, gender. Second time you loop, your list will be Linda 34F. The third time you loop, your list will be Joseph 8M.
With no spaces.
Well, so the first time you loop, right? You have name, age, gender, it's split into a list. So you have name, you have age, and you have gender. right? Because that's what you split the first line into. And then the second time you reach, this will be Linda now, this will be 34, and this will be F. So your list changes depending on which iteration of loop you're on. Unless you explicitly save this list somewhere, it's going to be replaced the next time you go through the file. Okay. Any other questions? Yes.
It just has to do with something you said earlier, like for I and range, for example, range 3.
Yeah.
In one of the assignments or the exercises, I did like for I in range 3 as dot reline, for example, and that way I don't need to read the line 3 times.
Yeah, you can do
right?
that too.
So that does it 3 times.
Yes.
Yeah.
Then when you're talking before, you said that it goes to
Right, well, if you say range 3, it's only 3 times. It only goes up to 2, that means it's going 0, 1, 2, so that's still 3 times. It just doesn't do 1, 2, 3, it's 0, 1, 2.
Okay,
That's
sorry,
it.
I misunderstood you earlier and thought it just goes to 2.
It does go to 2, but it's just going from 0, right? So basically when you're saying in range 3, you're counting the first 3 numbers, but to compare the first 3 numbers are 0, 1, 2, and not 1, 2, and 3, because you always are counting at 0. All right, so now we're gonna move on to a related topic.
I think we should take a break.
Yeah, okay.
Yeah, so
Take a
come
break.
back in 10 minutes. Yes, 4:17. Yeah. Nice.
Water.
Yeah, I figured this is like you make less mistakes. Yeah, one of the reasons I started trying to really like this strategy. I think I could. All right, so.
First of all, I was just
So I think it was like a kind of slightly, it was kind of slightly the value is gone. So, sorry, let me say that. So when you pop something from the dictionary, you're getting rid of the key value here. Inside the dictionary, the value is gone. So the value is but after you pop that in the dictionary, now is
That's the case.
Actually, I used to
So what's happening is you are not saving the dictionary. You're asking, you're deciding to return that result.
Oh, I got you. And that's why it's sending me string as well.
At the bottom of the
But now if I wanted to check what dictionary is, not the tag.
Mine doesn't.
I want to get empty dictionary.
Yeah. So what you have to do is save the dictionary into a separate way first, and then pop the key value from that dictionary. Because here you're not saving it.
So I do this, and this is, and then I say this dictionary top, and then I can.
The spreadsheet. So not the one, not the like not the system that Marcus uses. It's the one that like. Have you been looking at your spreadsheets? Because
So I didn't be able to contact, and so yeah, I think I have, anyways, and I think I have 36% of just the course, which is 14%. Did you say? I just want to confirm, because that's just me with the national those actual individual things. From bottom where it
that's not the one.
because there's nothing there on the page.
That's yeah. You should be looking at that. So there's a post on that. So it's like pinned notes.
And like if And why does a lot of I'm not.
So what we just
I think this.
why don't we
I think you
giving you lines. I know.
Yeah, I know, that one makes sense.
I know that.
So that
Why did you?
Now, that's even weirder. If I think that are putting it back like this.
No, I know what I'm giving. I know why it's giving. I know why it's not.
You're gonna wanna double check it, I don't know, yeah, I'm not trying to give you a hard time.
Why is it giving?
So
that's
you know the classic you did so like even if you get the quality numbers, you still fail to quality.
Yes, that's right.
That's why it makes sense to get more than 36%.
The users. Not
Okay, I've seen the name, but I don't remember, what's the name of this? Yeah, so like that portion of the outside.
That would make sense.
So it's a pin, and if you forget, just email me and I'll give you that.
It just didn't break, but it just appears like that. There's a previous
Okay, so if we're talking about then
just know like zero. Because except for don't catch anything. It could be syntax error, it could be, well, not a syntax error.
So there are three elements.
Runtime error is runtime error is something like that, index, a method, find a place that doesn't exist. So this will catch all runtime.
Oh shit! So you're saying, oh shit!
We don't want to do this.
You're saying that
Yeah, it's kind of sketchy.
I think that means this, if you index this, you're gonna
Well,
get.
it's like say, it's
Minus one.
and then there's a cliffhanger. This cliffhanger breaks, it kind of like this. I don't see anything. So you don't know what to do.
Oh, string, okay, so. Why do you see an index? One exclude and the last index is minus
But somebody else is like, you're gonna get more cares of her, so like,
See, that's what it is.
so you're gonna feel it once.
Oh, that's when you want to try.
Okay, so
There's something and not to catch it.
how up to 5. So we're going to
I'm gonna do this.
so you're going to get
Sometimes between this word and
This guy's watching.
then I'm doing this. 3 hours,
so 5. So now, okay, what comes before 4 is and of course the end is never. So we specify something before the everything all of the lines. That's right.
Because the docs choose yes.
Well, if you happen to know that.
So it's just
you
because
know
of the box. Actually, it's
Sorry. Oh, what does W do? So W is the right mode, meaning you're opening the file in a mode such that you can write this. Yes. But if there's already stuff in the file, then right,
Look at this.
yes.
Does that make sense?
Let's go back over to the parts foundation.
Okay. Oh boy. So you got like a 0. Okay. Send me an email. I'll definitely consider. I normally don't do this, but you're theoretically asking me to make the last part. So that's good. I'll consider.
Is it the palace?
Well, either is fine.
Yeah, it's all
Yes. Palace. I think this is.
I told the TAs they had.
Oh, that's just an email.
Yeah, I think that's what I told. It was either Monday or Tuesday.
That looks like it's a to me.
Yeah.
Is this like a state?
No, I never actually had this course. Kind of. Basically go through your own sizes, and then instead of just looking at it,
So
actually all
go through try and do it.
and then what did you want?
And look at the solutions and try to go through every solution.
Oh,
That's cute.
It's good to look at that and make sure it's actually correct. Because most of the time it's absolutely right. Yeah, that could be around.
It's easy.
But that's the people still sound.
Because if this wasn't working, it was just so it wasn't wrong. So our market was saying,
well, you shouldn't drop the table if it exists. I mean, you shouldn't recreate the table. You should only recreate the table if it doesn't, like if it completely doesn't exist, or if the user says
Actually, you know what I really like doing? I like looking at the photos.
right, but the create table function should if nothing exists, or if the user asks for the database to be related. So you made this.
Oh, it's underground. It's underground. That's not.
I was gonna say, this.
To be honest, I don't think we can see that.
Okay, on the pre-training run, yes.
Okay.
And for and of course, that's why brought cable.
No, damn it.
Right, so if the table didn't exist, it was raised like a physical except that.
Hey, that's fine, yeah. If you got the North Star, you got the North Star, right?
Yeah.
Yes, because there's other, because you can do the same thing in a simpler bit.
Yeah, that was my problem. And she's like, I was supposed to
You kind of, like, I mean, if that's the only way to
None of it. Actually, you can go to accounting.
So I was like, oh, I saw that skill, except I think this is
that's really bad.
I never knew everything.
You're gonna get your butt kicked for that. assuming my TAs are.
Very great.
Oh, you're the guy with the. Okay, good.
Oh, yeah.
Okay.
So that's the. Is that that's a shadow on the side.
Adding to the condition.
No, that's great. It's okay to go for time. I don't think anyone else is.
Add to the condition.
Sure.
Or I didn't even know.
Yeah, no problem.
So it's gonna be all I is
Oh, what do you mean, like, okay, but, I think it's okay. And that's just regular switch.
Hi, guys. So most of you are back, so we're gonna start. Hope that was a good break. I know I needed it because my voice is like dying. Now we're gonna talk about the last two topics, which are databases and SQL. And it kind of leads off from where we left off with CSV files. So I know that a lot of people think that this is like the hardest part of the course, that it's not directly related to anything else in here. But there are two reasons to talk about databases. One of them being they're one of the most important topics in comp sci. And regardless of where you work or what you do, you'll be interacting with databases somehow in your life, whether directly or indirectly. So like every time you do an image search for cute puppies or cats or whatever, Google Images, that's when you talk about the database. Every time you go pull money out of a bank, every time you use YouTube or Facebook, all that stuff is on databases. So it helps you know how it works. And yeah, it's a really useful skill to have, even if you're working in a hospital or doing lab research. Having these database skills can help a lot. And the good thing about SQL is that it's not Python specific. There's some versions of SQL along with different programming languages and used independently of Python. So yeah, it's good to know that stuff. So what is a database? Like David said in class, a database is just a well-structured collection of data, and the data should be easily stored, easily retrieved. So data is often stored in the form of tables, where the headers are the properties, and each row represents an entry. And all this together is called a schema. So for example, if we have a very basic image search thing here, we have certain attributes. So we have an image name, uploader, image size, and search tags, right? So you saw some of this that's really similar from your labs. With the entries, the attributes are the columns in your header, and then like each entry has each of these attributes, and each entry in this case would be an image. So again, databases are made of tables, and we know that the databases can also convert a table to a CSV file. And I'll just give an example. So in this case, we have this table called uploads with the attributes image name, uploader, image size, and search tags, and these entries. The stuff that Dodge represents more entries that we're not going to talk about. So we're going to consider these ones. So suppose that this is the schema used by an image search platform, something like Google Images. How do we search for all the images that contain the tag weekend? Can anyone give me a rough idea of what to do? So each of these images has a bunch of tags. Those are keywords associated with the images. How do we find all the images that have something to do with weekend? Any idea? Like not actual like code, but just like a basic idea of what we want to do. Yes.
Well, you want to select an image from. You would want to select an image or where weekend in tags is true.
Yeah, basically. So we want to select some image name from our uploads table where the search tag contains weekend. Now this is pseudocode, meaning like this is the idea behind what you want to do. Well, how would we go about implementing this? What would we use? Any ideas? Okay, so it's gonna be SQL and it's gonna be a query. Right, so our SQL query is going to tell the program what to do with our table. So in this case, we want to look for something inside this uploads table. So the first thing we care about is this from block. So from uploads, we'll first select this entire table. So it knows now that we're looking for something within this table. And then now we want to select some image name where the search tag contains weekend. So we have two things that contain weekend, images 1134 and CSCA20 F18. Both of these have weekend in the search tags, right? So this where block will isolate the exact entries we want. And then now we want the image name. So the very last select block at the top, that'll select the image name, so the pink. So this will actually give us a tuple of image 1134.png and DSC2342.tif. Any questions about that? So if you're being asked to trace a query, think of it this way. Given our queries, in this case, select image name from uploads where search tag contains weekend, the first thing you want to look at is a from block, because that tells us what table we're selecting from. Right? We can't do anything until we have a table to begin with. So this from block's our starting point. It tells us we're starting from this table. And then we care about the where block next. We want, we want only the entries where this condition is true. In this case, we want only the entries where search tag contains weekend. So that narrows it down a little bit to just these two entries. And then the very last thing we want to do is get the image names. So then we're ignoring the columns, uploader, image size, and search tags, and we're going to focus on just this. And then we can ignore the header as well, so we're just getting the image names. So that'll give us a tuple. Any questions about that? Yes?
So this code that you wrote, what is it going to output?
So I said what?
No, like what? No, I know that that's what it is, but what is that? Is that like what kind of data is that now?
So it's going to be a tuple, right?
That's a tuple.
So every time we perform an SQL operation, it's going to be a table. So for example, from upload, we'll select the entire table first. We're saying we're working with this table to begin with. The where narrows it down to just the elements in this, to just the part of the table where this condition is true. So it's still a table. And then when we do select, we're selecting this part of the table where this is true. And then when we return it, we're returning the items in that table, which is the tuple of the two image names. So all that is part of the SQL query. Yeah, so when you call, so remember in your assignment 3, when you get the assignment table using the SQL query, in the very end, so in the end of it, your goal is to get a tuple of the things that match your query, right? So there has to be that bridge between your Python code and the actual SQL query. And that's in the .SQL. We'll cover that in just a bit. We talk about queries first, and then we'll talk about how it connects. Okay?
Question here.
Yes.
So you said that's like pseudocode though, so is that the proper way to write if you're looking to see if something is in your list that is one of your columns in your table?
So we'll get that in just a bit. The idea behind the pseudocode is this. A query defines the parameters of the search, but depending on the version of SQL you use, the exact syntax will be slightly different. But this is the idea of it, right? It'll always be the same structure.
Okay.
So in the case of PySQL, which we're using here, that syntax works. But if you're using like MySQL or some version of Java, it might be like ever so slightly different, but the idea is always the same. And right now we're more concerned about a bigger idea than like the actual syntax.
In SQLite 3 then, if one of your table columns is a list, what would be the proper way to write for what we've done to see if our thing that we're looking for is in that list?
So you can actually grab the entry and then check to see if it's in there using the in keyword, right? The way you would check when it's in the list.
Okay, so you'd say where blank is in, or just say blank in this column?
I didn't cover like columns in
That's
the
why I'm
indices.
like, I want to learn.
So I never covered the fact that you can have lists in your columns.
Okay, so that's not something we need to prepare for.
Don't worry about that, but it's just like the idea I'm giving you right now. There'll be similar stuff we'll cover later, but the idea is you want to select some attribute or column from some table where some condition is true. And in this case, I use .contains, which I'm not sure if PySQL has it. It's a MySQL thing. But as long as this condition, so search tag contains weekend, as long as that is true, then we'll select that column.
All right.
Okay, so right now we're more worried about the idea of how that works. Okay, so back to this idea. when we write a query, again, the first thing I want you to think about when you're tracing it is this from clause. So from, we have to select from some table, right? If we don't specify which table we're selecting from, it doesn't make any sense. So this from block indicates your starting point. It'll be the first block to run, and it tells the rest of the query which table we're selecting from. Because it can be more than one table. And we're selecting the right one actually contains the data we need. And then once we have this table that we're selecting from, we can do select and where. I'm going to talk about select first. From select, we want to make sure that our argument is a column or a set of columns in the table. So for example, if we go back to our table here, we had image name, uploader, image size, and search tags. I can do select image name, or select image names and uploader, or select image name, uploader, and image size. But they have to be valid columns in our table. So if I'm saying select year from image name from this table, it won't work. It's going to have a column name called year, right? So as long as we're selecting valid columns, you're good. And the other thing about select is we can actually use a star to denote that we're selecting all the columns. So we can read that as select everything. So if I have select star from my table, it's the same as saying select everything from my table, or select all columns from my table. And then moving on to the where clause. So where indicates what condition we want to be true before we select. So in this case, it's technically optional, but the where block is the actual search functionality of it. So if we're searching for the columns where something is true, we need that where block. So if we have just select add tables, so we're basically just narrowing down the table. We're narrowing down the table horizontally. So we're eliminating certain columns, but then this where block is eliminating it vertically. So we're taking out certain entries. So if we have a table,
Just use the other board.
oh, I didn't know there was one more.
Yeah.
Okay, so if we have a table, so if I have just select, then I can say I want to select this column and this column. But then if I want the where and have a where block, I can narrow this down even more by cutting it horizontally. So it's like basically your select is your like vertical search. It's like it searches horizontally, whereas your where block searches it vertically. So then combining both, you can narrow it down to an individual cell by isolating it vertically and horizontally. Does that make sense? Okay, good. All right. So again, SQL. It's a database management system, meaning it's not quite like Python. Python is what we call a computational programming language. So you can do computations, you can use it to program a robot, you can use it as a calculator, you can do all that stuff. SQL is exclusively focused on the database. So it's not quite the same as Python. And SQL can be made to work with different programming languages using certain APIs. So for example, the one we're using for Python is CSCA20 F18. And that's where you have to import, that's where you import the module. So when you're importing the module, you're importing the API to get the functionality.
And in case you're wondering what an API is, it's a way to get like one, group of programming code to talk to another group of programming code. But don't worry too much about it. Yeah.
It's the same as just call it a module.
Yeah.
It's basically the same thing. All right. So when we work with the database, we have this general structure we always follow. The first thing we have to do is first import the module because that's what gives you the functionality. So the first thing we have to do is import SQL3. And then before we work with the database, we have to connect to our database using the connection. So SQL3.connect, the name of the database, the connection to the database. And once you're connected to it, you need a cursor. So cursor equals connection, not cursor. And if you were in my tutorial, I had to repeat something over and over again. Anyone tell me what it is? Yes?
The cursor is the object.
Right, so the cursor provides your database methods, right? So if you want to do stuff, you have to, if you want to do it to database, you have to modify it using a cursor. And then so after you got the cursor, you can do all your stuff to the database. And once you're done, you can do connection.commit. This is the one exception. When we're saving to the database, we want to save using the connection, not the cursor. And connection.commit to save as like Control S or Command S on your keyboard to save a file. So that'll save your changes to the database. And once you're saved and you're done, you can close the cursor and close the connection. Same way you would close the file. You'll notice there's no with open block this time, so you have to remember to close the cursor and the connection manually before you return. Not after you return, because once you return, the function's over, and you come back to that'll be ignored. So make sure you do that before your return block. So you close the connection to the database, so someone else can use it. Any questions about that? Yes.
Are we gonna go over what we can use the cursor for?
Yeah, that's coming up next. All right, so manipulating the database. The cursor is the link to your database. In other words, if you want to just link to your database, you have to reference it using the cursor. So if you want to think of the database as an object, like a string, list, dictionary, or whatever, then you can think of the cursor as like the database object. So like I have my class repeat over and over again. The cursor is the database object. Why don't you guys all do that right now?
Cursor is the database object.
Nice. So we asked earlier, how do we actually use the cursor to modify the database? Well, the way we do that is through the .execute method. And I know that a lot of you've seen different methods. There's, list.sort or .append or whatever. Every method does one particular thing. .execute is a little bit different. It doesn't do any particular thing in the way you normally think it would. .execute actually does whatever you tell it to do. So it's that bridge between your Python code and your SQL code. So .execute will take your SQL query and then perform that query on the database. So it's kind of an all-purpose function. It's like the middleman. You tell him what to do, he does it for you. So .execute on its own can't have tables. On its own, it can't select anything. It can't delete anything. But it'll do whatever you tell it to do using the SQL you pass into it. Do you have any more questions about that? Yes.
I was telling him about an analogy we made in the tutorial with the guy in the box.
Okay, yeah. So I made a lot of analogies, and one of them I made for execute was, think about this. It's kind of dark if you think about it, but imagine you locked your friend in a closet, and you know what's in the closet. You can't get the stuff yourself, but you can tell your friend what to do, what to get for you, right? So your friend is a .execute. What you tell him to do is the SQL query, and he'll get it for you depending on what you tell him to get. Same kind of thing. Like the guy in the room, standing there, like all sad and depressed, he won't do anything until you tell him what to do. So make sure you tell .execute what to do in the language it understands, which is SQL.
So I guess there's a hole here, and you need to tell him what to get.
Yeah, exactly. And then he'll pass it up the hole.
Yeah.
So think about .execute as like the sad guy in the room. You tell him what to do, and he'll do whatever you need him to do. So basically, that slave friend locked into the room, in the dark room. It's pretty depressing. That works too, but it's more memorable. It's more memorable when we talk about slavery. In the worst kind of way.
Yeah, it is a result from psychology that people tend to remember these dark things better. Yeah.
So he's the cursor, right? The guy.
Yeah, the guy's the cursor. And the command you're telling him is your SQL query. And then the things on that shelf would be the things in your database.
You know what's your database, but you just need that database.
Sorry?
You know what's in your database.
Right, you know what's in it, but you can't actually get it.
I guess you can think of it like when you go to the TDC, there's a window that you can't reach through, but you can see what's in the store. So you can reach under the slot and tell the guy to pass you something, right? Yeah.
That's a lot less dark.
Yeah.
So that works too. But yeah, that's what .execute does. So always remember that SQL queries are written and passed to execute as a string, right? So your SQL query is going to be one of the arguments for .execute, and the SQL itself specifies the operation. .execute just does it for you. So you need to tell it what to do using SQL. So having said that, there are a couple common tasks we can do using .execute. The first one being creating tables. Before we talk about that, we're gonna talk about this. Drop table exists, table name. So before you create a table, you wanna make sure the table doesn't already exist. If it does exist, you wanna get rid of it first, so you're not creating a big mess of like the stuff that's already there and whatnot. So before you create a table, you can use drop table exists, table name, to look in that database and see if there's a table with that name already. If there is, it erases it and sets it up from scratch. So the first thing you wanna do is that. And then once you've made sure that your table is not already in that database, you can create the table using create table. And the syntax for this is a little bit tricky. When you create a table, you want to make sure you give it a table name, and then indicating in parentheses what the column names are and what the type is that goes into each column. So for example, if I want to create this table we had earlier, where is it? If I want to create this table we had earlier, then I would have to say create table uploads, and then in brackets I would have image name text because it's a string, uploader text, image size integer because it's an int, and then don't worry about that. You're not going to be adding lists. But yeah, you have to specify the name of the table, the name of the columns, and the type of variable that goes into each of these columns. And they're a little bit different between SQL and what you're used to seeing in Python. So a string str in Python would be text in SQL. A float becomes real, and an int becomes integer. So just remember that. And I think some of you asked before, does the case matter? Does it matter if it's uppercase or lowercase?
In this class, we're using the convention that all reserved SQL keywords like integer, select, where, they're all capitalized.
So it doesn't actually matter for the program, but it helps make that distinction between what's Python code and what's an SQL query. So you can look at your code later and be like, that's all caps, that means it's SQL. That's lowercase, that means that's Python, right? So it just makes it easier for you. All right, moving on. There are some common table tasks, like select column from table where some condition is met, which is the same structure we saw earlier. And that's kind of like a search, kind of a search command, where you want to select some columns from some table where that condition is met. And that gets passed next to as well. The next thing you can do is you can insert values. You can insert into table values and then a list of all the values in the data. Except that list is in two things. We have a bracket full of question marks, and then a data parameter, which is either going to be it's going to be a collection. So it can be a set, a tuple, a list. But one thing we have to make sure is that data has the same amount of arguments as there are question marks in that bracket thing we put after values. Why? Because if we have a table like this, we have 3 columns, meaning we need, every time we insert an entry, it has to have 3 attributes, one being image name, one being uploader, one being image size. So if we want to insert this data, CSCA20F18, upload the Skittles with image size of 45, then we know that there are 3 things that you can count. One is the image name, one is the uploader, one is the image size. So 3 question marks, each one corresponding with a column. I can think of those as like a slot for data to go into. So then, in this case, for passive query and data, I know that the CSCA20F18 will go into the pink question mark, goes into the pink column. The uploader goes into the blue question mark, the blue column. The image size goes to the green question mark, goes into the green column. So all has to line up. Yes?
Data always has to be a tuple even when you only have one question mark, right?
Right. Except it doesn't have to be tuple necessarily, you can pass it a list as well.
In all the examples, in all the examples I showed in lecture, I use tuples, but it can be anything else. It can be a list, but pretty much you can think of it as, yes, it needs to be a tuple. And if it only has one thing in it, then you would have to add this comma in order to make it a tuple. Because if you don't add the comma, then it's going to be not a tuple. Yeah, and you need it to be a tuple. Yeah.
Any other questions about this? Yes? Yeah. So .access is going to be a bridge between the SQL query and the Python code.
Not really convert, but like what you showed before about like this is string, it's a
Yeah, so when you insert, when you create the tables, the type of variable that goes into the columns matters. So for example, if I'm creating this table here, then image name would be text, uploader would be text, and image size would be integer, right? Because it's string int, which in SQL is text integer. Does that make sense? Yes. And last major topic.
What is the advantage of doing this question marks as a placeholder one versus just doing it?
What do you mean?
Okay, so are you talking, what do you mean by putting it?
I mean,
like string formatting?
Without question marks, that you can just, that you can just put inserts into the table.
Okay, now I'm going to need to erase this.
So no more bullets.
So you're basically asking why are we doing this, right?
Yes, because I know there's a very down.
Instead of doing maybe, instead of doing what?
Instead of putting question marks within saying that which kind of what you want to insert, just say insert.
So just write the values you want to insert?
Yes.
Okay, well, I think in this particular example, we happen to have written into our code the values that you want to insert, right? So you know when you're running this code, you're trying to insert DSC2342.tiff, blah, blah, right? But you don't always know in advance what you're going to want to insert. You'll recall from the Pokedex assignments, the third one, at A3, right? You didn't know what values you wanted to insert ahead of time. You only found them out as you ran through a CSV file, right? Yeah, you want to say?
Yeah, but in this case, if we set values where we're gonna put whatever's in the data instead of using the question mark, it wouldn't work.
So do like this.
Yeah.
Yes, yeah, that would work.
That's what I.
The idea is like if you know exactly what you're inserting, then this will work. But most of the time, remember like a looping through a file, going like getting the same thing as it goes. In that case, it's inefficient to hard code things, right? So it makes more sense to have this if you're looping, or if you don't know exactly what you're going to be putting in right away, and you know that it's going to be constant.
Didn't you tell us in class that it's kind of dangerous to have insert into values data, because then you can do stuff that like what you insert in without the question marks and just delete your whole database?
Yeah. So I'm glad you said that. You're correct. But that doesn't technically apply to this, because in this case, we happen to know exactly what we want. So like the programmer who wrote this code wrote DSC2342 and whatever, right? And you can generally assume that the programmer who wrote it is not going to give you malicious information. However, I think you're kind of talking about the case where we use the string formatting method to like stick like string text right into our SQL query. And we passed in values that the user gave us. So you cannot assume that your user is going to be nice to you. Your user can enter whatever they want, and that may give you bad results. That kind of thing is called a SQL injection. However, in this case, that's not a concern because we're not taking anything from a user. So yeah.
Any more questions? Yes.
Oh, I just wondering that question you just answered. Is the data part have to be a control, or can it be a?
If you're hard coding it by inserting it directly, then no, it doesn't. But if you're doing it this way, then it has to be.
Yes.
Okay. So it seems like that's it for this part. Our last topic that we really talked about is table joins. So when are joins useful? Well, joins are useful when we want information that's spread across more than one table. So we can't select from multiple tables but join first. So the time joins is we want to relate this data in some way that makes sense and combine it for one table that we can perform a single search on. So in this case, I believe you talked about left joins, right joins, inner joins, outer joins, and cross joins a little bit.
Yes.
But focus mostly on everything other than cross joins.
Yes.
Okay, perfect. So yeah, we'll talk about all of these today, and we'll kind of like ignore questions because they're not all that helpful most of the time. Okay, so if you think about tables if you think about data on tables in terms of Venn diagrams, then a left join looks like this. It's all the stuff that is in table A, so table on the left side, and the stuff that's shared between both tables. So in this case, syntax we select some attribute or column from a left join B on A dot key equals B dot key. So when the column names are the same, where some condition is true. So we're adding an on block. So we have to join on some condition, and in this case, we choose to join on the columns the names are the same. So again, left join takes all the stuff in the left table and the stuff that's common to both the left and the right table. So, for example, if we have two tables, A and B, A being movies and years, and B being movies and genres, and we left join them, then on where A and B have the same column name, then we see that A and B both have a column called movie, but year and genre are different. So when we left join this, we get something like this because we have the columns for A and B, but in terms of the entries, we only see the thing that show up in both A and B, right? So we see that Avatar shows up in both, and Titanic only shows up in A. We're ignoring grown-ups because it shows up in B, but not A. Any questions about that? Right, so if we recap, Avatar shows up in both. Oops. So it's going to be the one that has both year and genre filled in. But Titanic, we only know the year from it from table A. We don't actually know the genre from it. So that's when we kind of get to know. Any questions? No? Okay. And now, right? Yes.
Where you have the equals there, do you need to have one or two equals because you're doing like a comparison? Is
It's
it okay?
SQL, right?
Yeah, in SQL, the
It's
syntax
single
choice
equals.
is okay.
Yes. You can use either if you want, so single or double.
Okay, because I've been using double.
Yeah, it's fine.
Okay, and now we're going to talk about right joins, which is basically the same thing, except this time we're taking everything in B, and the stuff that's common to both A and B, and then ignoring the ones that are only in A. So again, for the same two tables, you see that the movie column is the same, but year and genre are different. So we're going to take everything in B, which is going to be Avatar grown-ups, and we see that Avatar shows up in A as well, so we're going to get the year from that, but we're not actually going to know the year for grown-ups because it's not in A. So our table's going to look like that. Any questions? Okay, perfect. And now inner join. Inner join is a little bit different. It's just the things that are common to both tables. So in order for it to show up in the inner join table, it has to be both in A and in B. Can anyone tell me the benefit of this? Okay, it has to be the nulls we saw earlier. Yes.
You won't get any nulls in your table.
Right. So in this case, we're guaranteed to see every column filled in for our join table. So again, given A and B, we see the movies are the same. We see Avatar in both. So that's going to be the one that shows up in our inner join table. And now we have both the year and the genre for Avatar, because it shows up in both. So when we inner join it, we're going to see Avatar actually 2009. So we have no null values. Good. And then full outer join is probably the most, I want to say broad of all of them. And that takes everything from A, everything in B, and everything shared. So again, with the same tables, we see that movie is the same, so we're going to be joining on that. But this time we're going to be taking Titanic, Avatar, and grown-ups. And then once we join that, we see three columns, Titanic, Avatar, grown-ups, except we have a couple nulls in there because we don't know the, Titanic's, yeah, the year and genre should be flipped for all of them. I don't know why I named the columns wrong, but.
Well, you technically didn't specify what you're selecting, so let's pretend you were selecting. Yeah.
Yeah. So Titanic, we're gonna know the year, not the genre. Avatar, we're gonna know both because it shows up in both. And then for grown-ups, we'll know the genre, but not the year. Yes.
Should we see 4 columns if we're selecting all?
No, because it combines the columns that.
In SQLite, you will.
You will?
Yeah. So in SQLite, you'll see A.movie, B.movie.
Interesting. Okay.
Yeah.
I didn't know that. Yes.
So if you wanted to select on that table, like I remember the lab when you had to make the you select the people who haven't returned their books. So like where like return, like date returned is null like a string, or like how do you select?
People know like none in Python.
Okay.
It just denotes that the access is allowed.
So you'd be like where date returned
Is null, which means it hasn't been returned.
Okay.
Yeah. So like it's different in other languages, like in C or Java it's null. In Python it's none. In JavaScript it's none. It's null. It just depends on what it's called in languages. In SQL it's just null, or we see none.
So what was the thing you said you didn't know? I missed that.
The fact that if this SQL query was select star, so you're actually going to get 4 columns. You're going to get a.movie, b.movie, and the 2 other columns. Yeah, it's kind of annoying, to be honest. Yeah.
And yes.
So if we see the 4 columns, we're gonna have one movie column with a null in it, and we'll have another movie column with a null.
That's right. Yeah.
Yeah. So everything it doesn't know, it'll have it null. So try to grab what it knows from each 2 columns, and then everything it doesn't know about the pattern null. Any other questions about joining to database success?
What would you put, for example, in select?
This would just be select everything. Right? In this case, I have selecting where just done it out because like we're only really focusing on the join. Yes.
In that case, for full outer join, you don't need on a.movies and equals b.movies. If you're not specifying a certain column to join on, I guess.
But you are, because we are. Well, you're probably thinking of cross join, right? Because for full outer join, you're still trying to join on a column.
Okay. So you would get 4 columns regardless of what you join on.
In all of the joins we've seen so far, you would have gotten 4 columns. Yeah.
Yeah. So at the end of the day, when you're trying to pick out which join to use, think about what data you need. If you need a full set of everything filled in, then your inner join will probably be the most useful because it fills in all the data. But then if you care more about data from, let's say, the first table, then a left join will work. If you care more about the data from a right table, then you do a right join. If you just want, everything there, then a full out join is a job for you. So the type of join you use depends on what your code is trying to do, and it depends on what your end goal is. And being able to trace these joins, you just think about what they're actually doing, right? So if you want to think about it intuitively, left join takes everything from the left, and the stuff that's in the right is in the left. So at the end of the day, it's still everything in the left. Except it reads values where it can't be in the right. Right join is everything from the right, and then reads values where it can't be in the left. Inner join is just the shared data, and full outer join is just everything from both tables. Okay, so try not to confuse yourself and scare yourself with these big words. It's pretty intuitive. And having said that, that's actually the end of the material I have prepped. So, yes.
Would you do like select star to take everything in there? And then,
Yes, you have the entire table with all the columns with the select star.
and then would you put anything for there?
So remember that select kind of selects columns this way, right? But where narrows it down this way? So let's say that I have like 10, let's say I have 10 rows. I just select all on some word block. The word block might mean I'm selecting 5 of these 10 rows vertically, but it all goes horizontally. Whereas if you don't have a where I selected all of them horizontally and all of them vertically.
Right. So in that case, would you have
If I want to see everything in the table, then I wouldn't have a word block. Yes. No, so select selects columns, right? So it cuts it out vertically, so horizontally, and then where will cut it out.
It's a bit of a semantic discussion, right? Because like if you were to take a cake in that shape, the select moves the knife vertically, and where moves the knife horizontally. But yeah, don't want to get too much into the semantics.
Yeah, basically for where, they're selecting rows, and then selecting columns. Yes.
For join,
Uh-huh.
there's 2 of them cannot be used. I remember right.
Yeah, so if we go back to my first slide.
I'm just gonna say for the exam, you can assume that they are all implemented. Yeah.
So PySQLite actually doesn't have full outer join or right join because if you think about it, A left join B, it's the same as B So A left join B is the same as B right join A, right? So you just flip the order of the table and just do the join for you. And then you can actually do inner joins, outer joins as well by just like flipping the position. Yeah. So basically the idea is like everything you can do with left join, you can do with right join. Everything you can do with the right join, you can do with left join. Everything you can do with inner, you can do with full outer. Everything you can do with outer, you can do with full inner. So you only full outer, you can do with inner. So you say one of the two. Yes.
I know for select your where condition, like if you want your condition to be like a specific string, like it has to be written as like a one item tuple. But that's not the same thing for like a float or a hint, right? Because like I remember there's the example where it's like where precipitation equals 1/7. So that whole thing with the one item tuple, that's just if you're kind of trying to select where like where your condition is a specific string, right?
No. So the one item tuple is when you're trying to execute a query. So let's say use our good friend cursor.execute. So like this. And then you have a SQL query that you're using with one placeholder. If you have one placeholder, you still need to provide a tuple with one thing to fill in.
Whether it's string or an int or float.
Exactly. So even if you knew that it was like the number 5, you would say the number 5, one item tuple.
Okay.
Any other questions about final exam or like any other topics in this course? No?
We're going to post the answer for chemistry.
I will, yes. Yeah, I'll do it like maybe tomorrow or something like that, yeah.
Will you have office hours?
Yeah, so I'll be holding my regular office hours, and any additional office hours I hold, I'll try to announce them like a few days in advance. Okay? Yeah.
Is the final exam similar to, like, is the layout and concept similar to the older exams that are posted?
Yeah, there'll probably be like tiny differences in style, but basically, yeah, the style and the difficulty will be about the same.
No multiple choice?
I'm not planning a multiple choice. Maybe, but don't count on it. Okay? Yeah.
Is there any other final we have other than
So I just actually posted the 2017 one, and I'm probably gonna start a Piazza thread asking you guys to post solutions, like your own solutions to it. Yeah. Yeah.
So the 61 had the time that has released
25 marks less than what? Yeah, I don't know what the mark code is going to be yet. I haven't decided.
3 hours?
Around 3 hours, yeah. Any more questions? Okay, well, I just want to get you guys to give Autumn a hand. Yeah. I'm probably gonna tell the department to hire her as like as a course instructor or something. Yeah, what do you guys think? You guys think? Yeah. Woo! Yeah! All right.
Thanks so much, guys. And thanks for taking this course. It was a lot of fun for me to teach you guys, and I'm sure David feels the same way.
Yeah.
A great bunch. Still have the final exam. If you have any more questions, just Piazza, it's holding office hours, and yeah.
Yeah, and I'll be here if you guys got questions. So.
Happy studying.
I could have sworn on the in-class example, like, there was one where you wanted to select precipitation table, and it was like, you said select blah, where precipitation equals 1/7.
Show them the art.
Or it wasn't where you inserted the table, or select star from precipitation where city equals 1/7.
So I think I looked it up. So in that situation, I think
Yeah, if you get let's say small calculations. So if it has something.
Oh.
Obviously, you don't need another. That's
On the 8th, like, I didn't know they I went from there, but. Okay, that makes sense.
So, whatever you selected gets you the list of all the sources.
Okay, so if we say select star, every line will be pupil.
Sure, yeah.
Every like line in our. And so.
I know.
Yes.
And like, you look exactly at it.
Also with the.
Is that still recording?
I know. It was like, I was like, you were discussing something. So you're just checking something in the and then you look at exactly what the count was.
And then you look so up the
Yeah, it was like exactly there, and like, what was it?
Well, you're on camera now.
I am.
We were gonna cover like time questions.
I was thinking of that, yeah, so the question, I have posted the 2016 final, which is already posted.
Oh, we're just gonna do the final questions today?
If we have.
Yeah, I guess if we had extra time, we could.
Okay, so there wasn't like a separate problem set that you had.
No.
It would have been the exam.
Yes, exactly.
Okay, so if we go through those, then we can do all the questions a little bit.
Yeah, so I had the 2016 one, and I also posted the 2017 one on the lecture section.
Yeah, it's like,
So yeah, if you want to
we do those.
Yeah,
Perfect, thanks.
I have a question. So you posted two, which one it does this get to which?
I forget, but I'll post that. So like it's something like whoever is like named my last name is best is Yes.
I think you look for voice department.
She's probably not good for you.
I put infinitely. I didn't want to.
Oh, okay, nice. Yeah, okay. Nice. Yeah, okay, well, I guess technically what I said was wrong. Alright. Alright, nice. I never even thought of that. See, it's generally like really bad style to modify this iteration, so. Really bad, It's bad because like theoretically you can make it work, but when a programmer sees 4i in the list, they're gonna assume you're gonna iterate through the list, but they're also generally assuming it's not gonna change. Or even if it does change, it's gonna change one element at a time, but it's not gonna grow.
Yeah. Still not pretty sure about it.
And physics, that was it.
Before you do the exam, you look at the all of them.
Is it all right?
The second because they have to be the ones who
Oh, no, I told you.
I did not do those papers. And he did.
You don't really.
Do that. You didn't get it right, or you didn't get it wrong. You lose too.
This is it.
Nice. Like yes. If you ask me for application, because he can't.
These are
Whatever the last chapter is. Chapter 17. Okay. Yeah. The difference. The one before chapter. Yeah. 16. So 16 is
No, 15 is option, 16 is beats, and 16 is the superimposition.
Maybe well, I don't know.
Right?
But yeah,
So
the final version is not using
That's
this.
a good complete use that.
That's what if I want to
I always read because the first time I read the instructions, no, I read the instructions. I got lucky. I read the instructions. I was like,
the values was
It would be final illustration, right?
how can I
If you were to do this also, you guys
So if you want to say before,
which we did not.
yeah, to take a kind of sequence from XDX becomes your TV. So we
Not
go
that
first
easy.
sequence query annex.
That easy one or?
That
If it's
So my people.
Annex derivative is the sequence
Oh,
query.
no, no, no,
That
no.
becomes simple to scroll.
You
You don't want to annex, it becomes 10
This
pages.
is final score of last year, okay.
Yeah, sure.
You know, it's not like
Because this is changed, the value at I is
X goes for 10 pages.
I
And I did that, like right now.
And then whatever's on the side.
So I know it goes like
Here,
10 pages.
Okay. So the only thing I need to do is
when Python is
that
executing
here,
it, I'm looking with like multiple lambdas. It's gonna check, is this X? If not,
okay, that's what I was thinking.
And the check terms, not even.
if it is, then yeah.
Oh, okay, so if I want to check.
I actually figure out like when I
But also when we dip, right? It's
like
all-
over this for example.
So we D at I.
And then
So D
I used to put like
I
equal if
Yeah, equals
and
I
then after that break
is equal to I.
and so that if it's
That's
actually if it's true
And
then
then,
it's gonna break and then return to the column. So
And
it's
then
like
if I print it, if I print this dictionary.
If you can do this, the reason being that programmers see this a lot and it's a convention and it's like, yeah,
D.
If you really have it.
If I run this, I should.
Okay.
Okay, so it was generally the same process works for files.
I don't know how it even
Files, except then you could move that. So.
Yeah, if you're writing in a file, then make sure if you want to write our